Hello, Professor and classmates. My name is Nathaniel Guzman, and I'm going to explain a little bit about my paper, Zigbee Security Implications in an IoT Product. So we all know how Zigbee is one of the most used communication protocols for the Internet of Things, specifically for some of the home automation devices that are coming out to the market, and also in the industrial side of the economy. So there's some misconceptions about Zigbee, about their security, about the security of Zigbee specifically, and the objective of the paper was not to criticize Zigbee in any way, but just to basically expose, based on the amount of research that there is, specific best practices when using the protocol in your projects. There is some downsides to the protocol, but there's also a lot of plus to use Zigbee, specifically because it's specifically designed for the Internet of Things. So in order for us to make a good assessment of the Zigbee protocol, we need to know more or less how it works. I give a brief description on the paper of the Zigbee security features and the assumptions. So the main assumption of Zigbee is that, first of all, it uses a symmetric encryption algorithm to encrypt the payload. It uses specifically AES on CCMO. So there is one single key to encrypt and decrypt. This key is the network key. The assumption when you design a Zigbee network is that for no reason this network key will be exposed under any condition. Based on that assumption is the following assumptions that an engineer or designer makes when working with Zigbee. The Zigbee networks can be configured in two ways. You can have we're speaking in security wise. You can have a distributed network in which each device is routed by itself, and each router handles the security by itself. There is no central authority to handle the assignment of keys. There is also a centralized approach, which is the one that's preferred, because you can have a trust center assign the keys and manage the joining process when a new device joins the network. Regarding the keys, Zigbee again uses a symmetric key encryption algorithm, which is AES. So it's extremely important that the network key is never lost. Besides the network key, there are other type of keys, which is the link keys. Link keys are then, as the name implies, is a link between two devices. So there is global link keys and there's unique link keys. A global link key is the one that's between the trust center and a node. And a unique link key is between two nodes that are not the trust centers. Specifically, the link keys are used to transport the network key under an encryption tunnel, is the way of saying it. That way the network key is not being sent unencrypted on the air basically. So there are different tools that are developed to penetrate the Zigbee network, or to get knowledge out of a Zigbee network. Something important that I have to say is that these tools depend on you having an antenna that's capable of receiving the Zigbee signals of the radio waves. Most papers, research papers, bought something called a Raven board, which is a USB antenna that can detect all the radio waves under the Zigbee standards. Well, not only Zigbee, but under all the IEEE standards that Zigbee belongs to on the MAC layer. And once you have this antenna, you use some sort of software-defined radio. Software-defined radio is basically, as the name implies, software that can actually send and control the radio emissions to and from the antenna that you bought, from the Raven antenna that I just mentioned. Based on the software-defined radio concept, some tools have been created to facilitate the penetration testing of a Zigbee network. In no particular order, I decided to choose the two most popular ones, which is Seagator and Killer Bee, as an example to my paper. Killer Bee is a firmware-based tool. What I mean with that is that you have to burn the Killer Bee program onto a Raven board. A Raven board being the board that you connect to your computer and has the proper antenna to capture the Zigbee signals. It's a command line interface. It's based on Python. Once you install it on the Raven board, you are able to send commands to the board and produce. No, you can do packet sniffing specifically, but also it has some extra features that you can do, if possible, network key extraction. You can do some packet sniffing. You can do some packet injection. But there's a new tool called Seagator, which is a bit newer, which is very developed, which is very good compared to Killer Bee, because Seagator has some other peculiar features. Seagator is based on Zigbee, which is a software-defined radio library in Python, and it's able to do sniffing, jamming, packet injection, replay attacks, denial of service attacks. It's a wider range of attacks. Killer Bee is capable of doing so, but not with as much automation. Also, Seagator, because it's not a firmware-based program, is capable of doing more advanced attacks. Specifically, it has a self-learning capability. When Seagator was published, it was a paper which the creator published a paper describing the different issues with the Zigbee networks, and they were able to, using machine learning algorithms, decipher some of the network commands used in a Zigbee network. This is a very good feature. In fact, on the paper that is used as reference on mine, they develop a table, and in the table, with the table of information, we're able to train decision tree classifiers in order to detect which network command was used. So this what basically means is you can actually, by sniffing the traffic, you can decrypt almost all the traffic without having the network key. The decision tree classifiers do not work 100% with all the commands, but there is a few that are very effective on. Seagator is very good at doing jamming, because the idea when you use one of these tools is that you're trying to force a reconnection or a reset of a node. This is mainly because once a reset of a node is produced, the node is trying to look for the coordinator or the trust center, and if by any chance you jam the real coordinator during that process and you get in the middle of it as a fake coordinator, you have a lot of control and you basically are inside. And that's one of the main ways that they are using Seagator. Something that's important that I want to mention too on my paper is the stance of the Zigbee Alliance regarding of who is responsible for what, specifically when designing a Zigbee product. And as we can read here, I'm going to read it, depends on the safekeeping of the symmetric keys, protection mechanism employed, and the proper implementation of the cryptographic mechanisms. Trust and security architecture reduces to the trust in the secure initialization and installation of key material. So they're placing all the responsibility on the designer and engineer of these products to make sure that the initial keys are and the process of joining networks, which is the one that offers the most risk when you're using Zigbee, they're putting all the weight of that on the engineer. So it's up to the manufacturers and responsible parties to make sure that when they design a Zigbee product, they take into account the limitations of the protocol and the way it operates. So based on all this information above, there are specific papers that include several ways in which you can take into account the pitfalls or drawbacks of Zigbee specifically, but they all conclude in similar ways to the principles that are shared here. There's a specific paper that I use as reference on mine, which is by the Department of Energy of the United States. The title of the paper is specifically about how to design Zigbee networks and best practices in security for Zigbee networks. The paper is written in 2007, which at that time it was still a bit on the early stages of Zigbee. Now it's way more developed. So there are some principles there that may not apply right now, but there are a few that they do, and those are the ones that I decided to highlight as the conclusion of my paper. Starting with multi-layer security, that means not only security in the Zigbee network, but also how hard it is to get to the device, because one of the ways that you can extract the keys for a device is by opening and reading the memory of it, or the trust center. If you're able to reach it, you can just see the default trust center key, well, that is going to be used on initialization of the network, usually written on the device or hidden in the device in some way. Device hardening. This means that you're not able to open the device or tamper with it very easily. This is, of course, a sword of two edges, because a double-edged sword, basically, because if you do this, you make it harder for maintenance and for the overall diagnostic of the network if it's needed. Network separation, what this concept means is that between the Zigbee network and the other networks like Wi-Fi, the internet, the cloud, there has to be a barrier, like a firewall, so that way if the Zigbee is compromised, you don't get inside the whole infrastructure. But by saying this, we don't mean that it's easy to get into the network, on the Zigbee network, but the fact that Zigbee doesn't offer multi-layer security by default makes it a bit more vulnerable. This is because the headers on Zigbee are unencrypted. The next point is regarding that. You need to enable all the security features. By default, some are disabled, but it's recommended you enable them all. If you can have application layer security, it should be enabled. You should enable multi-layer security, even if the Zigbee standard recommends not to do it as a practice, because they consider network layer security enough. Securing the trust center. If somebody can get to the trust center, you basically lost, the battle's already lost, because on the trust, once you have physical access to it, you very easily have access to the default key that's really on the device by itself. Address filtering. You should not allow any device other than the ones that are allowed to communicate on the network, and this is easily done. Node authentication. Using the link keys, you authenticate cryptographically that each node is the one that says who is, and out-of-band transmission of the initialization key, and trust center global link key, because out-of-band means that is, as the name implies, out of the radio waves, or in a way that is not on the wire even. So that way you reduce the possibility of the keys getting more or less stolen, but lost or grabbed or sniffed in any type of way. Based on the research that I did, these were the main best practices and takeaways that as engineers and designers need to be conscious of when using Zigbee as a communication protocol.